Welcome everyone. We are going to be spending the next 45 minutes chatting about SQL Pool maintenance fundamentals. So I'm talking about dedicated SQL pools, not serverless, right? Not a Spark or anything like that, right? For those of you who don't know me, my name is Bob Duffy, and strange enough, I build data warehouses for a living for a company called ProData in Ireland. I'm a certified architect, a certified master, an MVP, an analysis service maestro, and now a Power BI fast track certified architect. So I've been around a long time, and this kind of talk is really about my experience in helping customers getting their maintenance right on their dedicated SQL pools. So we are going to be discussing mainly two things. I'm going to be focusing out there's a lot of areas that I'm not covering that are more performance, such as data skew, and I'm also not covering non-clustered indexes and stuff like that, because that maintenance is almost identical to the traditional SQL Server. What I am covering is Columnstore maintenance and stats maintenance. So I'm just going to focus on those two because I only got 45 minutes, right? So do drop any questions in the chat. If there's a really cool question, maybe Andy or someone can pop up and interrupt me, or we can have a chat at the end, right? So let's start off with Columnstore. Hopefully everyone knows what Columnstore is, right? I mean, it's a ubiquitous technology now. There's a flavor of it in analysis services, Power BI, now in Parquet files, Open Delta, and SQL Server. So what we're looking at is the Columnstore technology in SQL Pools. Basically, you're going to have within your table that is a Columnstore, lots of row groups, right? About 1 million rows. Well, 1024 by 1024, right? So just over 1 million rows. So it's going to be compressed into those kind of groups, right? And you're going to have this delta store for any inserts or deletes, right? So that's the Achilles heel of the Columnstore. Is it doesn't really handle inserts and deletes within the Columnstore. In fact, version 1 was read only. It didn't even have a delta store. So if you made a single change, you had to rebuild the entire Columnstore. Obviously, in newer versions, it lets you make changes, but it doesn't actually put them into the Columnstore. So you can get some performance issues with that. So we're going to look at how to optimize and fix that, right? So there's 3 problems that we're going to be looking at, right? One is what we call fragmentation, right? We want each row group that's compressed to have the maximum number of rows, which the kind of magic numbers up there on screen, right? 1048,576, right? Once you've got that, you've got as many rows as you can possibly get into Columnstore. So we call that 0% fragmented. Any row less than that, it's not kind of dense, right? And you can get a situation where you've got significantly less rows than that. I mean, in some cases, like only 100,000 per row group. So we really want to fix those, right? If you've got lots of deleted rows, when you delete a row from a Columnstore, obviously a Columnstore's row group that's been compressed or closed is read only, right? So you can't physically delete a row from it. That's impossible, right? It's a bit like a zip file. So what it will actually do is it will put the deleted row into another area of the delta store, and when the query runs, it'll sort of contour it out, right? Obviously, that's going to have a performance impact and a capacity impact, right? And that deleted row is never going to be removed. Well, in some extreme cases, it will get removed if all of the rows in a row group are deleted, like a very big delete. Then there is a tiny background process called the tuple mover that might delete the rows physically. But when I go on customer sites, often they have huge volumes of data. It purely depends how your fact tables are being loaded. If there's a lot of deletes and updates, this could be quite big, right? And also inserted rows that haven't yet been compressed will be stuck in this row store, okay? And if there's too many in there, it can create a problem. Now, there is this thing called a tuple mover whose job is to take, if you've got more than a certain number, it might decide to compress them, right? So it's not completely that it doesn't manage itself, but in most cases, it's not going to manage itself as well as you can, right? So just to show you what fragmentation might look like, I've created a table with 130 million rows here, right? Based on VentureWorks, it's got a finance table in it, right? Now, the perfect volume would be 60 times 1 million, because then you'd get 60 segments. So if you have less than 60 million rows, you might be familiar with seeing a little warning appear saying, hey, you might not want to consider a column store for these smaller tables. Now, I wouldn't agree with that at all, right? You can get much better performance on 100K column store than 100K row store on certain types of queries, right? But it's certainly not optimal, right? You really want to have at least 60 million queries so you get that 1 million per distribution. So if we create this table, there's various DMVs that you need to get familiar with, right? So the first one I'm going to show you, this one was written by Microsoft, right? And it goes into some DMV tables that show you the row groups, right? If you're really nerdy, you can have a look. It's going to be looking at this DMV here, the store row group physical stats. But most people that I know use this actually view because it joins to stuff to make it readable. And when you look at that, you can see that I have a few rows that are classed as open. So they're in the kind of Delta store. And that's because I was inserting 130 million. So the 120 million is going to be 2 packed row groups. I'm going to be left with some overspill. So that's what that is. And then I'm going to have these closed or compressed row groups. One of the most important things that you've got to look at is your trim reason, right? And the number of rows in each row group. If you get that magic number 1048,576 and the trim reason of no trim, pat yourself on the back, right? You have essentially fully optimized column store, and it has a 0 fragmentation, right? So that's what. Oh, just realized I've got the wrong chat. So this is a perfect column store, right? Well, apart from the get sort of open row groups at the top of the table, right? So what does bad actually look like, right? Well, the Achilles heel of SQL Pools is if you insert small bits of data frequently, right? It really wants to have 60 million rows at once, right? And who does that, right? So here, if I insert 20 million, if I create that exact same table, but I insert 20 million rows and then look at what's happened, okay, if I look at those row groups, you'll see that now each row group only has about 333,000, right? So it's about just over a third of an optimal value, and the trim reason is bulk load. So if you insert a load of rows in a bulk fashion, it'll automatically create a column store on them, even if it's not a full one, right? So to make it easier to read, having to read through these 160 rows is really annoying, right? So the first thing that I created is this view called V Columnstore Stats. What this gives you is one row per table that aggregates up all of the column stores and gives you information to know if it's healthy or not. So for the column store, I can see the number of rows in there, the number of row groups, how many rows are in the compressed column stores, and how many rows are in the Delta store. Okay, so I can see the maximum row count and the average row count. Okay, and we can compare the average row count to either the maximum or the maximum theoretical value of a million or so, right? So we see here that we've got about 68% fragmentation because we've got about a third of a row group, right? So it's not really optimal there, right? But because there's so few data in there, we can't really optimize it anymore, right? Because it's only got kind of limited amount of data in there, right? But what if we insert some more data? So what I'm going to do now is insert another 20 million rows 5 times, which means I'm going to be back up to about 130 or 140 million rows. Now, when I do that and then look at the column store stats, I'm going to see now that I've got 480 row groups. The first example where I just inserted them in one go, I only had about 120 row groups, right? So now I've got 4 times as many row groups, okay? And I can see that the average row group size is not optimal. Like it's not at the 104.85.7 kind of 6. So I've got a fair bit of fragmentation, okay? I've also got some open rows as well. So this is what perhaps poor density looks like, right? So you've really got to look at this average size and perhaps the max size. If the max size isn't getting up to 104.85 kind of 7.6, it's cutting out early, and we're going to have to look at why that is, right? So that's what bad looks like, right? How do we fix it? Well, you can run an index reorg. If I was to run this command here, it would take all the row groups that weren't at the optimal size and it would try and recompress them to get to the optimal size, right? Now, this is an online operation, right? So, you know, but it will need a bit of CPU, right? Now, it's a lot of hard work to individually run these commands. So I'm going to introduce you to a framework that I published on GitHub, right? So if we go to GitHub and click on this link here, there's a maintenance solution that you can run that deploys the views and the stored procedures that I'm showing you in this demo. And a stored procedure there called Columnstore optimize, which you can specify what tables, what kind of density threshold, and a few other parameters. So I can reorganize by calling that stored procedure and setting the density threshold to say, hey, find me any column stores that have 25% or more fragmentation, right? And when I run that, it'll go through my data warehouse and issue all of the commands to reorganize it, right? And then when I look at the end result, I will now see that I go from 480 row groups to, how many row groups do we have now? Was row groups? No, sorry, v column source stats, the second one. Okay, I've gone to 300 row groups, so not quite a 50% saving, and I can now see I've got a little bit more. Now, it's not a big table, so I'm still at 26% fragmentation, right? So I've still got a couple of row groups because I didn't have enough data in there, right? So you don't, you're still going to have a bit of fragmentation if you've got small amounts of data, and generally we don't worry too much about tables that have less than 120 row groups, right? Now, I've written this stored procedure copying a lot of the concepts from Ola Hallengren's framework. So, for example, it creates a command log where every time it does a maintenance activity, it logs it into a table. So after it's done its maintenance at night, you can put a report on top of it. I'll come in and say, right, it did this index name. This was the command that it ran. This is when it started. This is when it finished. And in the extended information here, it tells us how many row groups there were before it did its operation and what its fragmentation was before it started, so that you can see if it's improved, right? So that's an example of merging of the row groups to try and improve the density, right? Now, we were looking at fragmentation caused by a bulk load, right? So anytime you have small amounts of data, and bearing in mind anything under 60 million is kind of small, right? You're going to get this kind of bulk load trim reason, right? Now, there are other trim reasons, right? So if I go to here and look through my data warehouse to say, show me all of the row groups ordered by the trim reason, let's see what sort of trim reasons I have, right? Now, this isn't a very big one. Reorg, let's see what we've got at the top there, huh? Yeah, so null means it's not been trimmed yet, so that's going to be an open row group, so that's a delta store. Auto merge means I mentioned this process called a tuple mover that will in the background try and merge row groups, right? Now notice the tuple mover has taken them from being about 350 to about 700 because it's merged 2 into 1, right? But the tuple mover isn't going to be 100% efficient because it's like Lego, right? If the Lego pieces are too big, it can't make the perfect size out of the small ones it has. So it's merged 2, but it couldn't merge a third, because if it merged a third one, it would have had more than that kind of magic number and it wouldn't fit, right? So I'm stuck with about 30% fragmentation there. Okay, so that's a bit of a downer, right? So the kind of tuple mover helped a bit, but not as much as it could have done. Bulk load is obviously caused by small inserts, and then no trim is that magic one where it's gone all the way, right? Now there are other reasons which you're probably going to see in the field, right? These two here I commonly see on custom sites, right? Memory limitation means that when it builds the row group, it needs a certain amount of RAM to store all of the segments in, like all the columns. If it doesn't have enough RAM, it will cut the row group early, right? Because it'd be like, well, I've run out of RAM, that's it, I'm going to have a smaller row group, right? So the obvious thing that you can do to fix that is to give it more RAM, right? Which in terms of SQL pool, that means probably running under a different resource group, right? So one of our customers, they were running their maintenance under the small RC resource group, and they were getting a load of memory limitations. So when we upped that to a larger resource group, they weren't kind of getting that anymore. They had larger row groups and all the queries ran faster, right? So it's definitely worth checking that you don't see this. Now, this dictionary size is a little bit harder to fix, right? When you have a large string in a fact table, like a degenerate string, a degenerate attribute, it's got to build a dictionary object, right? And there's a hard limit of 16 megabytes for the size of that dictionary object, right? And no amount of resource group work is going to increase that, right? And when it runs out, it'll just stop. So you basically want to avoid large degenerate strings on important fact tables. You want optimal analytical queries, right? Ideas are obviously don't use large strings as keys, right? And if you really have to have a large degenerate, you know, something like a JSON blob, can you move it to a different table if you want that one table to be optimized, right? Otherwise, you're going to find your column stores, this 1 or 2 columns or segments are causing the rest of the table to not be optimized, right? So there's a trade-off to work out there, right? Now, common question, is it worth it, right? Obviously, your mileage may vary, right? As a test, I got the smallest optimal table that you can have, 60 million rows, right? Just to be clear, I know people might be thinking, hey, why is it 60 million rows? Like on an on-premise, it's 1 million rows. Well, it's 60 million rows because on a SQL pool, you have your forced 60 distributions. So effectively, when you create one table, you're actually creating 60 tables. So that's where that kind of limit comes from. And what I've done is I ran a basic aggregate query, like sum blah on the kind of table. When I had optimal row groups, like only 64 row groups, don't ask me how it only created 64 because it should create them in chunks of 60, but somehow I got 64. I must have had 4 rows overspilled or something like that, right? It finished in 30 seconds. That's the blue line. When I had 582 row groups, because I've done a lot of bulk inserts just to like slowly load it, the exact same query took just under 60 seconds. So it's like 2x gain, right? Now that's just on this simple test. Your mileage may vary, right? So lessons learned is a reorg is what you need to do to merge those down, and that sort of incremental fact table where you're slowly adding kind of data every hour or every day is going to be an anti-pattern for getting optimized column stores, which you can fix with some maintenance, right? Now, how frequently you run that is up to yourself and how important the queries are, right? I know some customers who do the reorgs every day after the load before lots of analytical queries hit it. Other customers run it weekly, right? Because they're like, well, you know, it's not as important, especially if you've got something like analysis services on top of it, where you don't have as many users running analytical queries because they're going to be hitting another cache. So that's something that you've got to really judge, right? Now let's look at some other problems on Columnstore, right? If I create this sort of table here, I'm just going to create this with 6 million rows. I think, is that 6 million or 60? Yeah, that's 6 million, I think, right? Obviously, that's going to create a very small table, and it's going to be so small that it's probably not going to be more than about 100,000 rows per row group, right? So when I create that and query the Columnstore stats, I'm going to see that I don't have any compressed data at all. Look, compressed row count is null because all of my data is sitting in my row store. So this situation where you've got a small fact table or you've just actually loaded it, right? If you want to get the benefit of the column store, that's possibly not going to compress. Now the tuple mover will kind of run in the background, and if you do get enough rows in there, right, it may eventually compress it into a closed row group, but that could be too late for you to enjoy the benefits of the performance. So what you might want to do is close it early, right? So here's all the open rows. So it's about 100,000 per segment. A reorg will not close open row groups, right? So if I go alter index reorg, it won't work. So there's a special extension, reorganize with compress all row groups equals on. And what this will do is we'll take all the open row groups, close them. You're going to get these segments that are quite small, but at least they're in a column store and not in a row store, right? So there's probably going to be a bit of performance benefit there. Okay, so to do that, we have a stored procedure that will basically look at the column store stats, determine if the number of open rows are greater than the threshold supplied, and if there is, issue the relevant command with the with compress all row groups equals on. So when I run this stored procedure and then look at the column store stats, I see that after that has run, I've now got my 6 million in the compressed row count and nothing in the open row group, right? Now, obviously the problem here is as I add extra rows, I'm going to have to redo that because they're going to go into the open row store as well. Okay. Now let's look at deleted. So the next problem that we're going to look at is deleted rows, right? And one of the worst things that you can do performance-wise in a column store is an update, right? Because when you do an update, you effectively get a delete and an insert. So your delta group is 2 hits, right? One has got to put the new insert, the other's got to put the old delete. And when the query runs, it's even worse because it's got to go to the column store to get the original value, contra out it by deleting the value, and then use the kind of new row, right? So you'd imagine that, you know, it's a bit of work, right? So when I run that update statement, I can see on my column store stats. Yep, great question by Kevin there to share those notebook files, right? Actually, when you go to the GitHub, if you download the maintenance solution, on top of the maintenance solution, there's a demos which actually has the exact notebooks that I'm currently using. So you can do this actually demo at home if you want, but you would need a copy of the AdventureWorks or whatever in order to do that, right? So when I look at this now, okay, I'm going to see my deleted row group has 64,000 because that's how many rows I updated. but my inserted row group or my open row group is also going to have 64,000. So I've got a double problem, right? If I just issue a simple reorganize, so if I run this store procedure and say open threshold equals blah, go, it will issue alter index reorganized with closed groups or whatever with compressed all row groups equals on. That will only fix half of the problem, because you see now that when I run that, my open row groups are gone. So all of my open row groups are now in my column store, but I've still got my deleted row groups, right? Those are going to sit there forever. Well, unless the entire segment is deleted and the tuple mover manages to finish to figure that out, right? So what we can do is we can force a clear out of the deleted rows and a rebuild of all of the column stores that had those deleted rows threaded in them, all the row groups. The only way to currently do that is by a rebuild, which is an offline operation, right? So it's a bit more intrusive than a reorg, right? So when you run this stored procedure, if the number of rows in the deleted row count is greater than the threshold, so I've just put a threshold of 10,000 here, which is quite low, right? It will issue a rebuild command, right, which will completely rebuild all of the column stores, which will get rid of all of the deleted row groups. Okay, so that's how we take care of that. Okay, and once I do that, you can see that the deleted row count is now 0. I've gone from 480 row groups to 180 row groups, right? So, you know, half the size or whatever, right? Happy days, right? Quick note on productionization, right? If you've got an enterprise data warehouse like us, you've probably got fact tables or tables that you don't want to do maintenance on, like your staging area, right? Or you only want to look at the column stores on some tables like fact tables, right? So what I've done is I've copied the Ola Halligan style of how you can filter tables to do part work. So you can go at tables equals every table that starts with the word fact, except for tables that are in the staging schema, right? And you can also set a time threshold of, so in seconds, so that's kind of 1 hour. So what will happen there is it will only look at column stores in fact tables that aren't in the staging schema. It will run for an hour, and then at that hour, it'll start the last piece of work, and then it won't do any more works. So you can use that if you've got a small maintenance window each night, you can use that as a basis for doing the maintenance. Rather than trying to do the entire EDW at once, you could do an hour a night, right? Bear in mind that it could start the last job at 59 minutes and 59 seconds, but the last job could take 10 minutes. So it could take longer than an hour, but it's just it won't start anything after the hour, right? So that's how we time box kind of the kind of maintenance to make sure that we don't accidentally overrun in our maintenance into our load window, say, right? So that's some of the productionization, right? Now let's move on, because that's pretty much all we do on column stores. Now, I haven't covered some aspects of column stores, such as ordered column stores, right? Ordered column stores have a different problem. We can get a type of fragmentation where parts of the ordering are in one row group and parts are in another row group, right? And there's a way of detecting that I haven't implemented yet, right? So if you do have a lot of ordered column stores, this approach may not fully optimize those, right? Now let's look at stats, right? 3 common problems that we're going to look for in stats, right? One is if you create a stat and then the kind of data pattern changes a lot since it was originally created, that's what we call a stale statistics. And if effectively the query optimizer could make poor decisions. For example, it could do a seek when it should do a scan and vice versa, right? Because it doesn't know the cardinality of the data involved, right? You can also get a situation where you have a stat, but there wasn't really any data when it created it. So it's very common for it to create a stat, and because it doesn't know the number of rows, because the table's empty, say, it would just put 1,000 rows in, right? So if you ever look at your stats in a SQL pool and see 1,000 rows, you know that's not a proper statistics, unless you just so happen to have tables that kind of magically have 1,000 rows in them, right? It's probably going to be a missing statistic. So that's probably one that you might get benefit in updating, although it's such a small table that it might not matter. Overlapping stats obviously speak for themselves. If you have two stats that have the same column as the basis for the histogram, then they're not really helping things. No, it's just really wasted space, right? So the key thing is these stale statistics is really what we're kind of looking for. Now, the first thing is to obviously make sure that your auto stats is on, right? So if you run this query on the sys.databases, you can check that some of the performance features is on. Result set caching, query store, auto update stats. Now, version 1 of SQL Pools didn't have auto stats, but that's going back years and years and years, right? Auto stats has been a default for ages, right? So if you created your SQL pool in any recent time, you should definitely have auto stats on. But if you don't, you probably want to flick them on, right? Notice auto update stats is always 0. You cannot turn that on a SQL pool, which is why we need to do more maintenance on a SQL pool than we would on a normal SQL server like DB Engine, because a DB Engine is going to have auto update stats, but we do not have that on a SQL pool, right? So let's see the auto stats in action. If I create a table that has, oh my God, is that 10 million or 100 million? My eyesight can't. Yeah, oh, it's only 1 million actually, right? So when I create a table, I've created a view called VStats, right? Now, this is something that I've created, but if you download the GitHub library, you can rip off my work, right? More than happily. And this is just really querying an internal object called sys.stats, where it is 1 row per stats. So you can use this to determine what the kind of stat is. So I'm querying that, and I can see what the columns are on the stats. I can also see what the row count is, what the stats for the table think is the row count versus the actual row count. And that's how we detect if they're stale or not. If there's a difference between those two row counts, if my stats thinks there's 1,000 rows, but the actual table has 1 billion rows in there, I've got a massive kind of problem. So we track the percentage difference between the two, okay? And what would the recommended sample rate be? Now, if that's when I run a query, so for example, I run this query here to do a distinct count on a few things, it's going to look at the cardinality of these two columns. So when I run this, I can see the auto stats has kicked in and it's automatically added to statistics object for me. And if you're familiar with the on-premise SQL Server, you can, no, there's a DMV, but you can use DVCC show statistics and actually have a look at the histogram. So because it's an index on kind of date, I can see all of the dates in there and how many rows per date is maintained, right? So that's auto stats working. Now, that was good, but what does bad look like, right? So this time I'm going to create a fact table, but just put 100 rows in it, and I'm going to run a query just on those 100 rows. So the initial stats that are created are going to be created on this piddly amount of data, right? So when I do that, you can see that my estimated row count is going to be 100, and my actual row count is 100, right? I'm then going to insert 100 million rows, right? So I'm inserting a lot more rows. Then when I come back to query the stats, you'll see I've started, they're now completely stale because the original stat thinks there's 100 rows, but there's actually 100 million and 100. So there's a massive difference between what it thinks there is and what there actually is, right? So that's something that we should probably update that statistic. So as part of the view, we actually tell you what the update statement would be if you wanted to update that, right? Now, far too much work has gone into, well, when should you update? Like what sort of difference should you update that kind of stats on, right? I mean, very old thing was I'll update after 1,000 rows and at 20%, like in SQL 2005, it probably did that, right? SQL 2014 introduced a new algorithm which didn't make it into SQL Pools because they don't have auto update stats, which is where it uses kind of logarithmic. It takes the square root of 1,000 times the row count. So that's how a modern version of SQL Server works. So what I did is I got that algorithm to apply a dynamic threshold. So we can recommend if the row difference matches that formula, it means it's probably out of date, right? So that's what we do. The next question is, what sample size should I use, right? Do I do a full scan? Do I do a 20% scan? So the key thing here to understand, a SQL pool will only ever do a 20%, right? If you don't specify. So that's it's going to default. But if you look at the KB on updating stats for SQL pools, they also recommend that you probably don't want to use a 20% on a very large table, like on a billion row table. The recommendation is to use 2% because the histogram only has about 200 steps, right? So going through every single row, if you're only storing 200 steps, is going to be quite inefficient, right? So we want to use a sample size that's intelligent, right? One rule won't work for all tables because we've got massive table and small tables, right? So common sense would say something like this: on small tables under 1 million, a full scan is probably fine, right? So this algorithm, which I've completely forgotten where I got it from, I either robbed it from how SQL Server dynamically determines it in the newer versions on premise, or it might have been from one of the blogs that I've noted at the end of the talk. Square root of row count times 1,000 divided by row count gives you this sort of logarithmic function where it starts off at full scan, and as the table gets larger, the recommended sample size goes down. So when you're at 1 billion rows, it's about 3%. If you ever hit 10 billion rows, well, what's probably a 1% scan is enough, right? I did a performance test to say, well, how much faster is it? Definitely, if you're using a full scan on a billion row table on a DW100C, it takes absolutely ages. And as you go to 50, 25 and so, it's very much faster, right? So you definitely don't want to use a full scan on those big tables. It will kill you, right? So that's how we determine what scan size you want. It should be based on the number of rows in the kind of table. Special columns, right? There's one type of special column that I will mention, which is the ascending keys issue, because we pretty much always get that in a data warehouse. If you have something like a date column where you're loading a new day, like retail sales, I'm going to load the sales for today, and then the next day I'm going to load the next day and the next day, you'll find your old stats don't have your new dates in them. So when you run an analytical query, select where kind of date equals and my new date, it's not going to be in the histogram. And this was such a problem for Microsoft customers that they actually have an MSC article specifically on that scenario there, right? So the recommendation is those type of ascending key stats you might want to update as part of your ETL even, right? So after you've loaded, update just those stats for those ascending keys. So when the new queries hit, the new date values are found in the histogram, okay? So just show an example of that. If I get a fact table, delete all the data in 2013, my histogram, just look at my histogram, isn't going to have any data for 2013 in it, right? If I insert a load of data for 2013, then my stats are going to be out of date. So what we can do is on the stored procedure we wrote to optimize stats, you can specify schema, table, and column name. So I can say find any stat which has the date key in it and update that, okay? So in this case, it will then update the kind of stats, but only on those ascending keys, okay? Now, the last thing, I've just got about 2 minutes left to look at some productionization issues, right? So if you go to the GitHub resource, SQL Pools, maintenance, you'll see there is a single maintenance solution that you can run that will install all the stored procedures, all the sample views and everything. So all you have to get up and running by doing maintenance is just trigger these stored procedures and specify whether you want to do all tables or specific tables, all stats or only specific stats. We would generally execute this in, say, for example, like an ADF package. We would call the stored procedure and we would run that kind of nightly or weekly, right? So that's how we productionize that, right? And if you want to split the work up when it comes to the stats, you can, if you want to. Here's some examples of the sort of things that you can do to only specify certain types of stats to be updated, like those annoying ascending key issues, right? Okay, so that's a very quick look through some column store issues that you might want to look at, and some stats issues, and some sample code that I've written where I've kind of these are some of the resources that I use to actually kind of make that up in terms of where the decisions came from, on what threshold to use for determining if it's stalled, and what sort of sample rate might we use, right? Further links and references, just there. These are some of the links and references that were used to make up the views and stuff to that I used in examples, and these are some of the references that I used on the stats. I do have a couple of blogs that you can read about some of the concepts there, but a good idea is just to go to the GitHub library that I will drop into the chat. Alrighty, that's us finished, I think.